What's up? Hi, good evening. We are starting off with electrochemistry आज. Electrochemistry काफी भारी टॉपिक है because you need everything from grade 11. सारा physical chemistry चाहिए to understand it, but also it is very easy to understand conceptually. ठीक है. Questions करने के लिए there are a lot of new equations. We'll figure it all out together. ठीक है. सबसे जरूरी चीज as always, please read the NCERT. मेरी आवाज साफ आ रही है? Are you able to hear me and see me clearly? Let me know in the comments. What's up, Teethraj? Hi, Naina. How you doing? Good evening. Good evening. Yeah. We're starting electrochemistry. As always, hi Mehak, good evening. What we're going to do is हम लोग quickly NCERT को पहले देखते हैं कि क्या क्या कवर करने वाले हैं and yeah, we're going to do something interesting today. मतलब कि हम लोग NCERT से थोड़ा बहुत ज्यादा डिटेल में जाएंगे because I'll show you why. Let's open up the NCERT. Quickly मैं NCERT खोल के आपको दिखाता हूँ why we're going to go into a little bit of detail. Okay, ठीक है. NCERT में यहाँ पे लिखा हुआ है the first topic they want to talk about is what is an electrochemical cell and differentiate between galvanic and electrolytic cells. We will do this. We will do this. But before this, हम लोग एक link बनाएंगे between thermo and electrochemistry, जो सबसे ज्यादा जरूरी है. We will do that. ठीक है? We will define what is a galvanic cell, what is a Daniell cell. That's what we'll start off with. This will be most likely part 3. Part 2 is where we'll cover the first two parts of this. ठीक है? Nernst equation, I think part 3 है, right? So yeah, and बहुत so this is going to have around 7 parts. Okay, I intend to do this in 7 parts. That's the general idea. Okay, so the last part will be all of this lambda naught, etc., etc. After that, oh, 7 plus maybe 2, 7 plus 1 or 2, where we'll do the secondary cells and lead batteries. There is ऐसे सब चलेंगे. आज क्या करने वाले हैं? Today, at the end of today's session, you'll be able to understand this, and you'll be able to understand this. Right? ये काफी भारी चीज है. Do you know what this is? By the way, hi Varat, have you seen this? आपने NCERT पढ़ी है? Just give me a thumbs up if you know what is happening in this. First, यहाँ पे कुछ हो रहा है ना? Daniell cell, electrodes of zinc and copper dip, कुछ कुछ लिखा हुआ है. Then they are saying कि कुछ E external less than 1.1 volts equal to 1.1 volts and greater than 1.1 volts. These are great ideas conceptually, but I don't think they spend enough time. Hi, good evening, Lisa. I don't think they spend enough time explaining these ideas, right? Which is why students get scared. शुरुआत में ही भाई ये बहुत भारी चीज हो जाती है. So we'll do something a little different than usual. We'll go through a session and we'll come back to NCERT and see कि ये समझ में आया कि नहीं समझ में आया. ठीक है? That's the goal. That's what we'll do. How do we check if the class you are attending, any class, whether it's my class or your class, is it effective or not? Come back and read NCERT, you should be able to understand it. That's it. That's your litmus test. Okay. So we will do that at the end of the session. So stick around towards the end for that. Chalo, let's get back to the PPT and start. What is electrochemistry? Philosophical question? No. So historically, आप लोग जो है 8th 9th 10th साइंस से इलेक्ट्रोलिसिस पढ़ रहे हैं. इलेक्ट्रोलिसिस मतलब इलेक्ट्रिसिटी के कारण some lysis happening. Electrolysis, right? Electrolysis. What lysis? Some chemical reaction is happening because of electricity being passed through. What kind of chemical reaction? अगर मैं हिस्टोरिकली कोई भी मेटल का सॉल्ट ले लूं, whether it is say, just थोड़ा सा बात कर लेते हैं, talk a little bit about this, yeah, the history of this whole thing. Say I have AgA or AgB or AgC, where these are anions and they are all soluble. मैं उसमें करंट पास करता हूं, the same amount of current, and I get the same amount of silver deposited in all the 3 cases. Now this is what is interesting. You remember हम लोगों ने ये चीज कहीं और भी कहीं देखी थी कि irrespective of what kind of पानी यहां से लो या पानी यहां से लो या पानी वहां से लो, water always has the combination of 2H plus O, right? 2 H एटम और एक O एटम हमेशा H2O देता है, और इसका यही कॉम्बिनेशन है कहीं पे भी करो. Why? Because electrons take part in this reaction, and यहाँ पे भी similar things are happening. Electrons are involved. Electrons move हो रहे हैं from one to another, which is what leads to the deposition of silver. Although एक blue color solution होगा, yellow color, green color का, but the same amount of silver, if you pass the same current, by the way, gets deposited. So that is what is interesting. Same amount of current for the same amount of time. That is called electrolysis or Faraday's laws. हम लोग third या fourth part में करेंगे, maybe fourth or fifth part में करेंगे. To understand all of that, let's take a step back and understand electrochemistry होती क्या है. ठीक है, we have been passing current and maybe आप लोगों ने भी घर पे बनाया होगा. Maybe you have made this cell at home, right? Where lemon का जो है पानी में डालो and then you do this, you try and get some deposition of copper. एक वायर जो टेलीफोन की आती है. Have you done this at home? Hi miss. Have you done this sort of experiment at home? कि एक बहुत ढेर सारे कॉइन्स लो और उसमें जो है बीच में कुछ विनेगर डालो और बीच में एक थोड़ा सा strip डालो of cardboard and you can charge something with it. Yeah, you can like light up a bulb. Have you done this at home? School में किया होगा शायद. What I'm trying to say is there are two ways to this, okay, to electrochemistry. मतलब कि एक तो I can use electricity for chemical reactions to happen, or I can, through chemical reactions, cause electricity to flow, which kind of makes sense because what is a chemical reaction? कुछ electrons यहाँ से वहाँ जा रहे हैं. अगर if I have some way of controlling the flow of electrons, that is current. That's it. That's the broad theory idea. Okay, that's literally it. Hi, Smita. Yeah, this is the broad idea. It's okay, Mahek, अगर नहीं किया तो Akansha, if you've done it, that's great. That's great. It doesn't matter. It's fine. We'll look at the theory behind all of these things. मैंने जो सोचा कि अगर ये चीज आप familiar हो, you'll have fun with this. I made videos of this sort for your for 9th and 10th students, so it's was fresh in my head. Here, what is electrochemistry? We are trying to interconvert chemical energy to electrical energy. Everything in nature is about energy conversions, right? Thermodynamics में क्या था? Flowing of heat. You are converting one energy can transfer one form to another, but not never be created or destroyed. That was the first law of thermodynamics, right? You had delta U is equal to Q plus W. Then you said this work is what? This is PV work. Okay? ये याद है? PV work. PV मतलब गैस का expansion वाला रिएक्शन वहां नहीं हो रहा था. अगर रिएक्शन हो रहा था, then you said that delta H is delta U plus delta G RT. This is for reaction and this is for no reaction. थोड़ा सा मैं आपको रिवाइज करना थर्मो के आइडियाज भी. if you haven't done them already, you can check this out. Yes, Raj bhai sahab, exactly. Right? So these are things maybe you are already familiar with. Yeah. Now, what is an electrochemical cell? Both of these things together can be called an electrochemical cell. मतलब कि either I use electricity to cause chemical reactions to happen, or I harness chemical reactions की energy in such a way कि electricity passes through. मैं बहुत शब्द बहुत carefully use कर रहा हूँ. मैं बोल रहा हूँ chemical reaction, हिंदी में बोलो तो chemical reaction हो रहा है, और मैं अगर उसको separate कर दूं ऐसे कि जो electrons chemical reaction के उनको मैं control कर सकूं, control in the sense I can give them a path to flow, then that constitutes current. ठीक है? I know this is a little bit of a leap of faith. It will be clear to you very soon. ठीक है? Very soon मतलब कि आज के सेशन में, कल के सेशन में, 3-4 सेशन में, this will be second nature. Like, yeah, this makes sense. This is not no big deal. अभी के लिए थोड़ा मुश्किल लग रहा है तो this is theoretically it is a little bit of it's a crazy question या like थोड़ा सा complicated idea है. Ideal gas equation, PV equal to nRT, sure, that will also be used. If you want to check out my other session on thermo and all of that, I've given you the link. I'm also pinning the comment. You can go to that. This always happens. I don't know why there's no space here. 1 second, hold on. I'm going to give you the link one more time. This time it's not going to be messed up. Replaced. Okay, cool. The second one. First link goes to my sessions on NEET and JEE channel, and second link goes to our app, the BYJU'S app. You can check it out. Hi, good evening, BM Sharma ji. The maths author, is it? Anyway, so electrochemical cell क्या है? Either way, either electrical energy into chemical energy or vice versa. बार-बार बोल रहा हूँ. It's both of these things. There have been questions asked on this idea, and students mess this up because उनको लगता है कि electrochemical cell मतलब electrolysis. But even a galvanic cell is the same thing. What is a galvanic cell? What is electrochemical? What is a electrolytic cell? We'll look at it. This is easy because you have been doing this from a long time. Right? School में I think from 8th, 9th, maybe even 10th grade से आप ये चीजें करते आ रहे हो. क्या? एक solution लो, उसमें electricity pass करो, there will be some deposition of some metal. You've been studying this. Galvanic cell may be new to you, but you have studied this in 11th standard. Let me show this to you. एक बार. Now we'll go back to the NCERT वाला business. आपने पढ़ा है? Yes, you have studied this Daniell cell, galvanic cell. अगर आपने redox reaction में, if you paid attention, see, it talks about this is redox reaction का PDF. Okay. That's why I said this session is going to be a little different from the others because electrochemistry expects you to know a lot of things from 11th grade. ठीक है? ये Daniell cell इसमें फिगर तो नहीं आ रहा है, but it's the same figure that is there over here. Yeah, and ये सब भी चीजें हम लोग अगले सेशन में पढ़ेंगे. What is this table? What is the meaning of all of this? For now, the concept of Daniell cell and standard electrode potential has been dealt with. मैंने भी किया है, and generally आपने भी पढ़ा होगा redox reaction. Just a bit of a reminder. If you have not studied this, it will be a good time to revise all this right now so that it makes these sessions make sense to you. Okay, cool. What is a galvanic cell? I somehow cause two chemical reactions to happen in isolation, because of which एक reaction electron देता है, दूसरा reaction electron खींचता है. What happens? One reaction wants to pull electrons, the other reaction pushes electrons out. So if I make this awesome arrangement जहाँ पे एक push कर रहा है, एक pull कर रहा है, it's like there's a cycle, and then there's electricity coming out, उसको तुम निकाल के कुछ और कर सकते हो. That's what a galvanic cell is. Okay, we'll talk about it in some detail. Okay, a battery is an electrochemical cell. Galvanic cell maybe take 2 3 ऑफ देम साथ में रख दो, बन गया बैटरी। या इंटरेस्टिंग चीज है, सी आई एम यूजिंग अ न्यू टर्म हियर, स्पॉन्टेनियस केमिकल रिएक्शन से इलेक्ट्रिसिटी प्रोड्यूस होती है। मतलब कि केमिकल रिएक्शन अपने आप आगे बढ़ रहा है, मैं उसको कुछ, आई एम नॉट गिविंग इट एनी पुश, नथिंग, आई जस्ट मिक्स टू थिंग्स एंड रिएक्शन स्टार्ट्स हैपनिंग, और आई कनेक्ट, आई मेक दिस कनेक्शन। मैंने बोला था एक रिएक्शन की टेंडेंसी है इलेक्ट्रॉन प्रोड्यूस करने की, दूसरी रिएक्शन की टेंडेंसी है इलेक्ट्रॉन कंज्यूम करने की। तो प्रोडक्शन एंड इट डजंट मेक सेंस, रिलीज, लेट्स से रिलीज ऑफ इलेक्ट्रॉन्स एंड वांट्स टू एक्सेप्ट इलेक्ट्रॉन्स, एंड उन दोनों को हम लोग साथ में रख दें तो वो लोग अपने आप रिएक्शन हो जाएगा। we'll talk about how and why, don't worry, we'll talk about that. This is a spontaneous reaction. अच्छा, अच्छा, oh, so the other way around will be non-spontaneous? Yeah, we'll talk about that as well. पहले हम लोग galvanic cell की बात करते हैं, ठीक है? This is also known as a voltaic cell. Here is an example, a Daniell cell जहाँ पे zinc और copper electrodes है। Electrode क्या होता है? We'll talk about that as well. A galvanic cell is an electrochemical cell that produces electricity as a result of spontaneous reaction. सबसे best example है Daniell cell, which you have studied already, but it's okay. Here it is, okay? What's the idea over here? Electrons को हम लोग बाहर में, see, this is what I was talking about. You have a way for electrons to flow outside the circuit, okay? How? Through a wire. फिर अंदर क्या हो रहा है? अंदर ions flow कर रहे हैं. So inside ions flow and outside electrons flow. But एक बात बताओ, salt bridge in between, nice, but why can't I have electrons flowing inside this solution? क्या problem है? Why do I need ions to flow inside? What is this salt bridge? अभी तीसरा ने बोला कुछ salt bridge के बारे में. We'll talk about all this later. Yeah, hold on to your horses. इसके बारे में बाद में हम लोग बात करेंगे. The reason why I need to put a wire outside and not just connect यहाँ पे अंदर से ही, क्योंकि अगर इलेक्ट्रॉन इतनी छोटी चीज है कि electrons sure they get produced or they get released in the solution, but अगर वो मैं, if I don't give it a wire, मतलब wire क्या होता है? Metal conductor होता है ना. इलेक्ट्रॉन कहाँ जाएगा? जहां path of least resistance. You have studied this in physics. So if I give it a metal lead, it will go through that instead of going to solution. If I don't give it that metal lead, ये रिएक्शन हो जाएगा, यहाँ पे पानी में चलेगा, इलेक्ट्रॉन, you have no way of knowing what's happening. But because now say इलेक्ट्रॉन इस तरफ फ्लो हो रहा है, राइट, इस तरफ फ्लो हो रहा है, मतलब कि if electron being pushed out like this, some ions are moving inside this. तो ions यहाँ भी मूव कर रहे हैं, ions दूसरी तरफ भी मूव कर रहे हैं, and to make sure that ion movement keeps happening, that's what you have this solid bridge for. We'll do this in detail later on, but मैं आपको ऊपर से बता रहा हूँ. तीसरा, yeah, this is from physics. अगर electron flow इस way हो रहा है, then बारिश हो रही है बाहर, it's awesome. Can you hear it? I don't know if you can hear it. Then current जो है opposite direction में flow होगा. I'm revising things because electrochemistry needs physics, needs thermo, needs a lot of things. इसलिए मैं धीरे-धीरे आराम से कर रहा हूँ. If any of you have any doubt on this, please ask me. This is awesome and really important. Okay. So this is a basic idea कि spontaneous कुछ reaction हो रहा है. क्या reaction हो रहा है, क्यों हो रहा है? We'll look at it. Don't worry. आज ही बात करेंगे इसकी. Some reactions isolation में से left hand side में और right hand side में हो रहे हैं. Isolation मतलब मैंने दोनों को connect किया एक वायर से, ठीक है? इसकी tendency है to accept electrons, okay? And इसकी tendency है, tendency शब्द important है, to push electrons out, okay? And if you already figured it out, redox में इसको क्या बोलते हैं? Pushing electrons out मतलब oxidation, accepting electrons मतलब reduction. Don't worry, we'll talk about all that. Nothing will go over your head. आराम से करेंगे. Okay, that was about the galvanic cell, मतलब spontaneous reaction. अब दूसरा टाइप का क्या है? Electrolytic cell, मतलब कि we are passing electricity for reactions to happen. मतलब reaction does not want to happen, right? उसको करने का कोई intention नहीं है, but हम लोग जबरदस्ती उस reaction को करवा रहे हैं. This reaction is a non-spontaneous reaction. So by passing electricity, I am making a non-spontaneous reaction spontaneous. ठीक है? तो it is non-spontaneous, but by providing electricity मैं उसको spontaneous कर देता हूँ. Okay? Yes, need. Yes, need. Sure, we'll talk about it. We'll talk about that. बाद में उसके बारे में बात करें. Salt bridge right now is not important. अभी सबसे बेसिक चीजें हम लोग पहले कवर कर लेंगे. We'll talk about that later. Yeah. मैं आपको ऑलरेडी बता दिया, maintain electrical neutrality etc. क्यों क्या? We'll talk about that much later. Not important right now. यहाँ पे हम लोग इलेक्ट्रिसिटी पास कर रहे हैं फॉर अ नॉन स्पॉन्टेनियस रिएक्शन टू हैपन. नाउ यू नोटिस यहाँ पे कुछ बदल गया है. क्या बदला है? यहाँ पे देयर इज अ थिन स्ट्रिप ऑफ सम मेटल, देयर इज अ थिक स्ट्रिप ऑफ अनदर मेटल. कुछ यहाँ पे तो प्लस माइनस बहुत चीजें लिखी हुई है, एक बैटरी भी लिखी हुई है. तो बहुत चीजें यहाँ पे हो रही है, मेनी थिंग्स आर हैपनिंग, राइट? माइनस से मतलब कि इलेक्ट्रॉन्स यहाँ पे जाएंगे, करंट उल्टे डायरेक्शन जाएगा. तीसरा ऑलरेडी फिगर्ड दिस आउट. बट व्हाट इज एसेंशियली हैपनिंग यहाँ पे? आई एम फोर्सिंग इलेक्ट्रॉन्स टू गो इनटू इट. जबरदस्ती मैं यहां पे आई एम पुशिंग इलेक्ट्रॉन्स. ओके, व्हेन आई एम पुशिंग इलेक्ट्रॉन्स, यहां पे क्या होगा, यहां पे रिडक्शन होगा, जाहिर है. व्हेन आई एम पुलिंग इलेक्ट्रॉन्स फ्रॉम हियर, राइट, पॉजिटिव चार्ज, पॉजिटिव टर्मिनल क्या मतलब, इट पुल्स इलेक्ट्रॉन्स. इफ इट पुल्स इलेक्ट्रॉन्स अवे, मतलब यहां पे हो रहा है ऑक्सीडेशन. ठीक है, we are going to focus on this oxidation and reduction bit. सबसे जरूरी चीज है redox क्या होता है. If you have doubts in this, maybe you're not watching session live, बाद में देख लो, please इसको रिवाइज करो. ऑक्सीडेशन रिडक्शन क्या होता है in terms of electrons. I've already told you in short, but this is important. Okay, तो रिएक्शन खुद नहीं होना चाहता, बट मैं जबरदस्ती उसमें एक पोटेंशियल डिफरेंस, बैटरी मतलब क्या, E, right? There is some E or V, some voltage difference that is being created because of which ये चीज हो रही है. ठीक है, ओके. खैर, ये सब इतनी कहानी इसलिए बताए, नहीं 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 तीर्थराज ऐसा कुछ नहीं, तीर्थराज ऐसा कुछ नहीं, वो सब छोड़ दिए, ड्रिफ्ट वेलोसिटी वो सब चीजें छोड़ दिए. यू मे बी राइट, बट दैट्स नॉट समथिंग आई वांट टू गो इनटू एट ऑल. पुशिंग एंड पुलिंग फॉर मी फ्रॉम द केमिस्ट्री पॉइंट ऑफ व्यू इज द टेंडेंसी. ठीक है, टेंडेंसी की मैं बात कर रहा हूं. पुशिंग एन इलेक्ट्रॉन मतलब टेंडेंसी टू डू दैट, राइट. टेंडेंसी की भाई इलेक्ट्रॉन तुम बाहर जाओ, तुम निकलो, मतलब समथिंग इज रिलीजिंग इलेक्ट्रॉन्स एंड हेंस आई एम गिविंग इट अ लीड, तो वो बाहर चला जाता है, इलेक्ट्रॉन से बाहर चला जाता है फ्रॉम द यूजिंग द कंडक्टर विच इज द वायर, इट गोज आउट. दैट्स ऑल. Why? Because something else wants electrons, that is getting reduced. Okay, Teesraj? Sure. I don't mean कि जो है धक्का दे रहा है, actually it's just a tendency. And sure, electrons do have some drift velocity and all of that inside the conductor, but that's not something I'm talking about at all. You're right though, but that's not our focus in chemistry. Okay, ठीक है. The one thing that I want to talk about, galvanic cells and electrolytic cells are reverse of each other. Do you understand this statement? Any doubts in this first statement? I spent a lot of time talking about galvanic cell being a spontaneous process, electrolytic cell being a non-spontaneous process. I'm just asking you to now say कि same reaction जो spontaneous हो रहा था, मैं अगर उसको उल्टे डायरेक्शन में करने की कोशिश करूं तो नॉन स्पॉन्टेनियस हो जाएगा, तो आई कैन पुश इट टू मेक इट हैपन. दैट्स ऑल, दैट्स ऑल आई एम सेइंग. ठीक है, सो essentially since I've already set up the base right now कि redox reactions तो हो रहे हैं, क्योंकि एक साइड है जिसकी टेंडेंसी है इलेक्ट्रॉन पुश करने की, दूसरा साइड है जिसकी इलेक्ट्रॉन को पुल करने की टेंडेंसी है. ठीक है, इलेक्ट्रॉन को पुल करना मतलब इट इज एक्सेप्टिंग इलेक्ट्रॉन्स. इफ समथिंग इज एक्सेप्टिंग इलेक्ट्रॉन्स, रिडक्शन. इफ समथिंग हैज अ टेंडेंसी ऑफ पुशिंग इलेक्ट्रॉन्स, मतलब इट हैज फॉर्म्ड इलेक्ट्रॉन्स इन द प्रोसेस, व्हिच मींस ऑक्सीडेशन. और वो फ्री इलेक्ट्रॉन्स है, कहां जाएंगे, तो जिसको लेना है ले लें. दैट इज व्हाट वी आर टॉकिंग अबाउट. सो देयर आर टू half reactions, reduction, oxidation, that are happening. Is just that I'm making them happen in separate chambers, so I can take the energy, the difference between them. There's some sort of a potential difference between them. I can use that to furnish electricity. Okay? This is what is the most important thing so far. Okay, cool. So here are some examples of this. I'm trying out this 5 p.m. time, yeah, because I thought maybe 1 p.m. may not be suitable to you. ओके, क्रेजी साहब, आपको लॉग नहीं यूज करना आता है, गो टू माय डिस्कॉर्ड चैनल, आस्क अराउंड हाउ टू यूज लॉग एंड पीपल विल टेल यू. या विल टेक अ क्विक डिटोर टू टेल आवर फ्रेंड. देयर आर लॉट ऑफ पीपल हु डू दिस इन माय सेशंस कि मैं किसी की बात कर रहा हूं, बट वो लोग कंप्लीटली किसी और चीज की बात करेंगे. ठीक है, नो प्रॉब्लम, बट आई हैव क्रिएटेड अ स्पेस फॉर यू गाइज टू डू दैट, टू सेफली एंड इन एन ऑसम वे engage with your with people who you want to about this sort of conversation. Anything, किसी चीज पे भी बात कर सकते हो तुम लोग, as long as study related. So for that, go to this link, okay, over here on top of my head. Discord का link है, Telegram का link है. If you want to check out my session, you can do that. It's the pinned comment. You can check it out. I'm gonna get back to teaching now. All right? Okay, cool. So what is the redox couple? यहाँ पे ये M plus plus electron giving you M. What does this mean? इसका ये मतलब है कि मेरे पास एक मेटल स्ट्रिप है, दो मेटल स्ट्रिप है. ठीक है, दो अलग अलग इस कंटेनर में. दिस मेटल स्ट्रिप इज M, दिस आल्सो लेट्स कंसीडर टू बी M. इसका इफ इट हैज अ टेंडेंसी टू एक्सेप्ट इलेक्ट्रॉन्स, ओके, मतलब दिस इज रिडक्शन. ओके, कूल. इफ इट हैज अ टेंडेंसी टू गिव इलेक्ट्रॉन्स, टेंडेंसी की बात कर रहे हैं हम लोग, then this is going to be oxidation. This is good. Yeah, Teethraj, Neet Saab, Smita, BN Sharma, Mehak, Lisa, Varad, all good with you guys? Naina, are you following this so far? Yeah. So if I just reverse one reaction, reduction becomes oxidation. That is all I'm saying. कुछ fancy चीज नहीं है. Just very simple stuff. Okay, cool. So I have two electrodes. Electrode क्या होता है? Metallic conductor होता है, metal होता है. It should let electrons pass through it. That is what an electrode is. ठीक है? That's it. And it is in contact with electrolyte. Electrolyte क्या है? जो चीज डिसोसिएट हो जाती है सॉल्वेंट में. पानी हम लोग यूज करते हैं. Let's assume पानी है फॉर ऑल प्रैक्टिकल पर्पसेस. लेट्स अस्यूम कि समथिंग दैट यू पुट इन वाटर इट डिसोसिएट ऑटोमेटिकली. लाइक क्या? से A प्लस B माइनस पानी में डालो, NaCl है, दैट इज एन इलेक्ट्रोलाइट. ठीक है, पानी NaCl. ठीक है. एन आयोनिक कंडक्टर व्हिच मे बी अ सॉल्यूशन, लिक्विड और अ सॉलिड. कंडक्टर मतलब वायर वायर है, सब कुछ है. ठीक है. ओके, स्वीट. दिस इलेक्ट्रोड एंड द इलेक्ट्रोलाइट को हम लोग हाफ सेल बोलते हैं. ठीक है. एंड मैंने तो आपको ऐसा सिचुएशन दिखाया कि ये दो अलग अलग हैं, but it is possible to put them both together. But if you put them both together, this is going to die out pretty soon. Okay, अगर मैं अलग अलग रखूं, then I can kind of get a stable source of current, or I can do all that. But this is also possible. ठीक है, both these things are possible. This slide is, that's what he बोल रहा है. So this right here is example of a half cell. तो ये लग रहा है पानी, but इसमें क्या है? I've got some metal here. ठीक है, उस मेटल को मैंने ऐसे सोल्यूशन में डाला. दिस इज वेरी कूल. मेटल जिंक है, उसको मैंने सोल्यूशन में डाला. सोल्यूशन में भी जिंक है, बट दैट सोल्यूशन हैज जिंक इन इट्स आयोनिक फॉर्म. ओके, in a sense what I have done is I have formed this sort of a setup. ठीक है, जिंक और Zn2 प्लस. नाउ आई कुड ऑल्सो राइट इट लाइक दिस. दोनों लिख सकता हूं. दिस डिपेंड्स ऑन टेंडेंसी. कैसे लिखोगे आप? नेचुरल टेंडेंसी मतलब से स्पॉन्टेनियस मैं बोल रहा हूं. अगर स्पॉन्टेनियस रिएक्शन है, कैन बी ईदर थिंग्स. मतलब स्पॉन्टेनियस ऐसा हो सकता है कि जिंक कैन गिव यू आयंस, और जिंक आयंस कैन गो बैक टू जिंक. टेंडेंसी हमेशा रहती है इफ आई पुट इट लाइक दिस. ओके, या ऑलराइट. You good? All right. Sweet. So, one second. Yeah, so this is the tendency of stuff to happen. Okay, that's all this is saying. Oops, ये कहाँ गया? All right, ठीक है. This is a half cell. This is an electrode. Okay, this is an electrolyte. Electrolyte क्या है? The only difference in electrolyte I'm saying is कि to have the electrolyte जिसमें metal का ion present हो, so I have this sort of a tendency thing being formed. मतलब कि या तो वो metal से ion बना सकता है या ion से metal बना सकता है. It could be either way. How do we find it out? From something called the electrode potential, which is the focus of today's session. ठीक है, electrode potential. This is the tendency जो मैं बोल रहा था. ठीक है, उसके बारे में बात करेंगे. ठीक है. Some reactor metals have a tendency to go to the solution phase when placed in contact with their ions in the salt solution. If that happens, oxidation. मतलब कि अगर this is positive, then oxidation. But if this is positive, then reduction. बहुत लेमैन टर्म में यही बोल सकते हैं हम लोग. ठीक है. All right, sweet. Now, if I put the metal in the electrolyte and the potential difference, there is some sort of, and this is a little bit, this is where things get a little bit difficult to follow. There is some potential difference developed between the electrode and the ions in solution. तो यहाँ पे जो metal था और यहाँ पे ये था. So right over here, on the surface of the metal, there is some reason. We won't go into too much detail. If you want to, you can read up on it later. There's something called Helmholtz double layer, etc. ऐसा कुछ चीजें हैं. ठीक है. There is a reasoning behind some potential difference being created over here. उसी को मैं टेंडेंसी बोल रहा था. टेंडेंसी को मेजर क्या करेंगे? There's a way to do that. Okay, did I say that right? Hold on, just one moment. I have a feeling Helmholtz double layer किसी और चीज के बारे में. But let me just look it up. Helmholtz double layer. I think it is this, but I'm just checking it out. Whoa, did I type something? Okay, one moment. Hold on. Ah, no, sorry, that was about colloidal particles. This is something else. Sorry about that. I was wondering मैंने कुछ random चीज बोल दिया. I know, crazy, इसलिए मैं लिखता नहीं हूँ. That's why I don't write. But तू पढ़ने आएगी तो मेरी handwriting देखने आया. Handwriting देखे क्या करेगा? पढ़ के जा. So ऑक्सीडेशन पोटेंशियल क्या होता है? ऑक्सीडेशन पोटेंशियल इज यही टेंडेंसी मेटल बिकमिंग मेटल आयन, ठीक है? अगर ये टेंडेंसी पॉजिटिव डायरेक्शन में जा रही है, then yeah, cool, there will be some number attached to this. That number is basically this oxidation potential, ठीक है? So some metals, they have a tendency to get deposited, मतलब they want to get reduced, उनकी tendency उल्टा है, मतलब कि for this say Cu plus to Cu or Ag plus to Ag, this potential is going to be positive, so you'll say that this prefers to get reduced, ठीक है? Cool. So copper, similar setup, instead of zinc now putting copper in copper sulfate solution, ठीक है? तो ये छोटी सी एरो यहाँ पे ये दिखा रही है कि कॉपर आयंस वांट टू कम बैक एंड गेट डिपॉजिटेड ओवर हियर, उनकी मर्जी, एंड दिस इज देयर नेचर, ओके? दिस इज देयर नेचर, दिस इज नॉट मी डिसाइडिंग व्हाट यू डिसाइड, दिस इज देयर नेचर, ऑलराइट, ठीक है? And again, whenever metal strip is put in electrolyte, similarly potential difference develop होता है between the metal solution and its system. In this case, मैंने उल्टा reaction लिखा है, remember this. So you have to be comfortable in doing this, writing this reaction, that reaction, reversing it, and understanding by reversing a reaction, what does it mean actually? Yeah, इसका मतलब क्या है? Oxidation हो रहा है, reduction हो रहा है, ठीक है? So I've told you, I'll summarize everything that we've spoken so far, ठीक है? ठीक है? There's a potential difference developed between metal electrodes and solution, and we will put some numbers to it. Let's say 1 molar concentration, 1 bar pressure, and any temperature. उसको हम लोग standard electrode potential बोलते हैं. Now this E naught value can be positive, can be negative, can be zero. तीनों चीजें हो सकती हैं, ठीक है? Yes, thank you, Petra. Thank you. It can be any of these things. Zero. So here is an interesting thing, right? अब इस चीज को हम लोग measure कैसे करें? Now we have some E naught value. How do we measure it? How do I get this positive, negative या zero वाला number? मैंने बोल दिया कि होता है, but कैसे measure करोगे? Think about that. We'll talk about that toward the end of this session. Okay. ठीक है. So now zinc prefers getting reduced, तो हम लोग उसको लिखेंगे like this, and this value is positive. And if zinc wants to be oxidized, sorry, if zinc wants to be reduced, एक minute, yeah, if zinc wants to be reduced, you write like this. If zinc wants to be oxidized, you write like this. Now जाहिर है कि say this value is 0.76, then this value will be negative 0.76. Are you okay with this? Is this all right? Yeah, just from what I've taught you so far, मैंने आपको, I have not done any math, but can you kind of make that leap of faith कि हाँ sure, अगर ये रिएक्शन का पॉजिटिव है तो उल्टा कर दो, नेगेटिव हो जाएगा. जस्ट लाइक डेल्टा जी अगर x है फॉर दिस फॉरवर्ड रिएक्शन, देन बैकवर्ड रिएक्शन का डेल्टा जी माइनस x. दैट्स ऑल आई एम सेइंग, ठीक है? इनफैक्ट जो डेल्टा जी से ही आता है, we'll do that. डेल्टा जी से ही ये E naught आता है. We'll do that when we do Nernst equation. Okay, cool. ठीक है. And this is one thing that is important, and probably the most important thing in today's session. Oxidation always होता है एनोड पे, reduction always होता है कैथोड पे. This is how you decide what is the cathode, what is the anode. The reason I'm saying this is कि कभी कभी कैथोड पॉजिटिव होता है, कभी नेगेटिव होता है, कभी नेगेटिव भी होता है, कभी पॉजिटिव होता है. तो दिस साइन इज सेकेंडरी, ठीक है? मे बी जेई और नीट के लिए साइन प्राइमरी है, क्योंकि दे विल आस्क यू क्वेश्चन में साइन क्या होता है, बट तुम लोग फिगर आउट कर लेना. बट हमारे लिए व्हाट इज मोस्ट इंपॉर्टेंट, दिस. ओके, oxidation always happens at the anode, reduction always happens at the cathode, irrespective of what kind of cell, whether you have a galvanic cell, whether you have an electrolytic cell, हमेशा यही होता है. But galvanic cell और electrolytic cell में cathode और anode के साइन बदल जाएंगे. We'll look at that later on. Okay, great. ठीक है. So मैंने आपको दो हाफ रिएक्शंस के E naught बताए. अब उन दोनों को साथ में ले आइए. Then you will get the total cell potential. This is the driving force that pushes electrons away from the anode. Because what is anode? Anode का मतलब क्या है? Anode मतलब oxidation. Oxidation मतलब this. See, this is releasing electrons, right? Okay. So driving force that pushes the electrons away from the anode and pulls them toward the cathode. Why will it pull towards the cathode? Because at the cathode reduction हो रहा है, and this wants the electrons. Copper wants electrons for the reaction to move forward, so it will pull it toward itself. ठीक है? And ये this want or tendency, इसको हम लोग सेल पोटेंशियल बोलते हैं, इसको हम लोग यूनिट देते हैं वोल्टेज. All right, sweet. Now I can also call this potential energy per unit charge, per coulomb of charge. What? What does this mean? हाँ, इसका क्या मतलब हुआ? Voltage is defined as energy per unit charge. You may have seen a different version of this equation in physics, where you say कि energy is equal to V into Q. Have you seen this? Physics में पढ़ा है क्या? Yes, crazy साहब, वही exactly वही हम लोग next करने जा रहे हैं. ठीक है? Cool. So the electromotive force can also be thought of as a potential energy per unit charge. Okay? Yeah. V और हम लोग we will say E और E naught हम लोग बोलेंगे इसको. ठीक है? In chemistry. Interestingly, when no current is passing through, then this value is a maximum. As current starts flowing, ये E की वैल्यू घटती जाएगी. What? हम लोग फिजिक्स में बोलते हैं ना, when the circuit is open, जब सर्किट ओपन होता है तब द पोटेंशियल डिफरेंस इज E naught. As soon as I close the circuit, chemical reaction happens. अगर रिएक्शन होना शुरू हुआ, वो पोटेंशियल कम होता है, फाइनली जीरो हो जाता है. कीप दिस इन माइंड. पोटेंशियल जीरो होना आइडिया विल बी यूजफुल नेक्स्ट सेशन. मैं बहुत चीजें बोल रहा हूं जो अगले सेशन के लिए, बिकॉज ये पूरी चीज रिलेटेड है. ठीक है, अगली बात आज की थ्योरी की, वी विल टॉक अबाउट हाउ टू रिलेट, जैसे क्रेजी साहब बोल रहे हैं, रिलेशन बिटवीन डेल्टा जी नॉट एंड ई सेल. मैंने बोला था ना, डेल्टा जी अगर तुम रिएक्शन उल्टा करो तो साइन उल्टा हो जाता है, तो ई नॉट भी उल्टा जाए. एग्जैक्टली डू दैट. बट बिफोर वी डू दैट, लेट्स गो बैक टू एनसीईआरटी. एनसीईआरटी में एक जरूरी चीज थी दैट आई वांटेड टू टॉक अबाउट. दिस है ना, दिस मैंने बोला था ना, व्हाट इज द प्रूफ ऑफ यू अटेंडिंग अ सेशन एंड इट बीइंग यूजफुल टू यू? यू शुड अंडरस्टैंड एनसीईआरटी में क्या हो रहा है ना. एनसीईआरटी में क्या हो रहा है समझ में आना चाहिए. अब देखो, ये इन लोगों ने कुछ रियोस्टैट यहां बना दिया है. व्हाट इज दिस? व्हाट इज द रियोस्टैट? अ रियोस्टैट इज समथिंग दैट हैज वेरिएबल रेजिस्टेंस. आप उसको रेजिस्टेंस बदलते जाओगे, उसका करंट बदलता जाएगा, पोटेंशियल जो है बदलता जाएगा. ठीक है, सो इट इज सेइंग दैट इफ आई सप्लाई अ बैटरी, एंड यहां पे देखो मैं उल्टा कर रहा हूं. व्हाट इज अ डैनियल सेल? दिस इज अ डैनियल सेल. ओके, नेचुरल, दिस इज नेचुरल टेंडेंसी, मतलब कि जिंक बीइंग ऑक्सीडाइज, कॉपर बीइंग रिड्यूस्ड. ठीक है, आई डोंट नीड एनी फैंसी स्लाइड्स फॉर दिस, बिकॉज हम लोग वी आर ट्राइंग टू अंडरस्टैंड एनसीईआरटी, राइट? ओके, कूल. दिस इज नेचुरल. अगर मैं उल्टा चाहूं उसको करने का, व्हाट इफ आई वांट टू मेक दिस रिएक्शन ऑपोजिट हैपन इन द ऑपोजिट डायरेक्शन, देन आई एम सेइंग दैट ठीक है, समहाउ आई हैव मेजर्ड कि नेचुरली दिस प्रोड्यूसेस अ वोल्टेज ऑफ 1.1 वोल्ट्स. नेचुरली मैं इसको चाहता हूं कि रिएक्शन उल्टा हो जाए. सो टू डू दैट, व्हाट दिस डायग्राम्स आर बेसिकली सेइंग कि अगर मैं 1.1 से ज्यादा वोल्टेज दूं, देन ये उल्टे डायरेक्शन में चला जाएगा. आई एम गोइंग टू से दैट वन मोर टाइम. ओके, नेचुरली see what is happening. Zinc is getting oxidized, so this is the anode, this is the cathode. ठीक है, इसमें से इलेक्ट्रॉन निकल रहे हैं, so this is the negative thing because it is furnishing electrons. इसमें इलेक्ट्रॉन आ रहे हैं, this is the positive side, anode is positive, cathode negative. But look at this, ये नेगेटिव में मैं यहां पे क्या कर रहा हूं? Look at this, zinc is on the left hand side. I have connected this battery over here. ठीक है, and in this battery you can see some very interesting things. यहाँ पे negative terminal इधर है, positive इधर है, negative positive. As soon as I go greater than 1.1 volts, बहुत छोटा सा है, it's a small thing, but I'll zoom in. Look at this, look at this. यहाँ पे this is the positive terminal, this is the negative terminal. You see that shift? Think about this. इसके बारे में आराम से सोचो. I don't expect you to understand this the first time you read it, but सोचो इसके बारे में. Positive क्यों हो गया? Because now I've swapped it. Now see, here I am causing Zn2 plus to Zn, मतलब कि कैथोड बन गया ये फ्रॉम एनोड, मतलब कि यहाँ पे रिडक्शन हो रहा है. एंड ऑल्सो आई एम पुलिंग दिस, आई एम पुलिंग इलेक्ट्रॉन्स फ्रॉम हियर, सो कॉपर इज गिविंग मी Cu2 plus Cu plus 2 electrons which are flowing into this. इसलिए negative terminal है, ये electron push कर रहा है, ठीक है. So I have reversed the reaction and look at this. Here anode is negative, here cathode is positive. And यहाँ पे क्या था? यहाँ पे भी cathode positive, anode positive था, negative था, ठीक है. So interestingly, we have made the same reaction, but completely. देखो zinc कहाँ गया? Zinc here had a negative charge, right? Zinc ऊपर में negative charge था. When you come here, zinc is connected to the negative terminal, to the positive terminal now. You see? So cathode यहाँ positive है, anode negative है, but zinc का बदल गया. Okay? All right? Pretty cool, right? Pretty cool. So to make the non-spontaneous reaction happen, non-spontaneous कौन सा reaction था? इसका उल्टा. Opposite of this is non-spontaneous. But I make it happen. Why and how? I provide a potential difference greater than that 1.1 ulte direction and I make it happen. There you go. Khatam. Now you have understood galvanic cells, you have understood electrolytic cells. This is electrolytic cell. जब मैं external potential ला रहा हूँ, that is electrolytic cell. When I am letting things happen, that is the normal galvanic cell. बस, that's it. Cool. बाकी सब तो इसमें सेशन में सब चिल है. There's no big deal, right? Only thing I'll say is कि देखो, this is a theory, and you can go through some thermodynamic derivations if you want. I can share that with you later on. The maximum non-PV work that can be derived from a system is given by the modulus of delta G. Why modulus? Modulus because मैंने आपको दिखाया I can do anything. I can just, if a reaction is spontaneous, I can extract energy out of it. If it's non-spontaneous, then मैं जबरदस्ती उसको spontaneous बना सकता हूँ by going in the opposite direction. इसलिए यहाँ पे mod लिखा है, ठीक है? The maximum non-expansion or non-PV work that a system can do is equal to the decrease in Gibbs energy, delta G, ठीक है? Non-PV work क्या हो सकता है? Electrical हो सकता है. At our level, it is electrical. Mechanical, there are many things, but we'll focus on just electrical work. Yes, Teethraj, the other way around. You will have to connect the positive terminal to zinc for it to happen. आप समझ रहे हो? Teethraj. Good question. Good question. वो उसमें आएगा नहीं. You will have to do this. आपको करना पड़ेगा. You will have to connect the positive terminal to this, negative terminal to that, and have a potential difference greater than 1.1 volts. Then it will happen. Why will I connect positive terminal here? Because abhi zinc wants to get reduced. Not wants to. I'm forcing it to get reduced. It doesn't want to. वो तो चाहता है कि ऑक्सीडाइज हो. बट मैं जबरदस्ती उसको रिड्यूस कर रहा हूं. अगर मैं रिड्यूस कर रहा हूं तो मुझे उसको इलेक्ट्रॉन देने पड़ेंगे. अगर मुझे इलेक्ट्रॉन देने पड़ेंगे कैसे करेंगे? या यू विल डू इट लाइक दिस. ठीक है? Cool. We good? Yeah. All right. If it's getting reduced, it will furnish electrons, right? Zn2 plus. अच्छा अभी भी यही दिख रहा है ना. Zn2 plus electrons will give you zinc. So electrons देने पड़ेंगे. ठीक है. All right. Hold on. Okay. Cool. So the maximum electrical work obtained from a cell is delta G. There's a bit of theory. अगर आप चाहें तो उसके बारे में I can discuss it, but it's a little complicated. So I can give you the final result right over here if you want. This is it, okay? This is the final result. ये इसको derive करो. You take H equal to U plus PV, G equal to H minus TS, H U equal to Q plus W. Do all of these things, okay? The only extra thing I'm doing is I'm writing plus work of non-expansion. It's dq plus w. W को मैं expand करके non-expansion work लिख रहा हूँ. You cancel stuff out, you get this equation, ठीक है? Which finally just gives you this. Okay? If you substitute this right here, everything else gets cancelled out, and the only thing you're left with is this. Okay? If you want, I can give this to you. This is not a very complicated thing, but it's a derivation which is not relevant to NEET, or even for JEE, it's not relevant. But since किसी ने पूछा, so this is for them. Okay? How do you get that delta G is non-expansion work? That is what I'm showing you here. Very short में मैंने आपको दिखाया. ठीक है? All right. Cool. This is what I was talking about. All right. Let's go back to what we were talking about. ठीक है? So remember, मैंने आपको बताया था कि what was E by Q was equal to V? मैं उसी को यहीं पे कर रहा हूं सब्स्टिट्यूट, E नहीं, let's say energy, let's not write E, it'll get confusing. Energy by Q was voltage, right? So I'm going to say that delta G is minus Q into V, right, which is minus NFE. This is all, this is the derivation, this is the short derivation, short version of it. Yeah, how delta G is equal to minus NFE. Okay, why is there a negative sign? Because a reduction in this, if delta G is spontaneous, right, then E is positive. This is it. इसलिए there is a negative sign over there. Okay. Interestingly, this F जो constant है, what is this constant? This is called a Faraday's constant. This is a very big number. This is 96,500 coulomb हम लोग normally लेते हैं. This is the charge of 1 mole of electrons. If you're wondering where the heck did that come from? Remember I started this session by saying कि electrons are involved. How are they involved? If I take 1 mole of electrons, that has a charge of 96,500 coulomb. ठीक है? Cool. I told you बहुत छोटे छोटे मास, छोटा छोटा मास डिपॉजिट हो रहा था. That also has to do with this. When we learn Faraday's laws, we'll look at that in detail. So by knowing this delta G value, you can get EMF at that composition. Composition मतलब concentration. Concentration of what? देखो, ions are there. I have zinc and zinc SO4, right? So the concentration of this matters. अभी तो मैंने क्या बोला था कि 1 molar concentration, 1 bar pressure पे it is called E naught. If I change this, then you have to use the Nernst equation to figure out how this works. Okay, which we'll do in session 3. Okay, cool. So summarize things so far. Spontaneous reaction matlab delta G less than 0, E cell greater than 0. Non-spontaneous, delta G greater than 0, E cell less than 0. Any doubts so far? Are we good? Sab theek? Let me know. पहला सेशन है, थोड़ी थियरी तो होगी. ओके, अगर डेल्टा जी नहीं दिया है तो E कैसे कैलकुलेट करेंगे? This is an interesting question. Although nobody asked it, but I'm asking this question. It's interesting. There are two things I'd like to say. One, E is intensive. मतलब आप उसको ऐड नहीं कर सकते. जैसे कि डेंसिटी है, दैट्स इंटेंसिव. अगर आप दो चीजों को मिक्स कर रहे हैं, से पानी और कोई और शुगर सिरप, उसको मिक्स कर रहे हैं, you can't add the densities of water and the sugar syrup. What you have to do for density, you have to get total mass divided by total volume, right? That's what gives you density. You cannot do rho 1 plus rho 2 intensive property. That doesn't work. Similarly, E cell strictly cannot be added or subtracted. But what I can add and subtract are delta G values because this is extensive. Mass is extensive. Intensive, extensive, याद है क्या था? Do you remember? Intensive means कि if I go to one point and say, अच्छा, is property का, does it have any meaning over here? If this is the system I'm talking about, if it does, it's intensive. It does not, it does not. Also, another way to look at it, intensive does not depend on the quantity or mass of stuff. Okay, extensive depends on mass and quantity of stuff. तो अगर मैंने mass बढ़ाया तो delta G बढ़ जाएगा, right? If I take 1 mole, if I take 10 moles, then delta G values will change, but E naught will not change. That's what I'm trying to say. Okay, all right, great. तो फिर करें क्या? ई सेल कैसे निकाला जाए? मेरे पास एक इलेक्ट्रोड रिएक्शन है, एनोड पे ये हो रहा है, कैथोड पे ये हो रहा है, ठीक है. आई हैव टेकन टू डिफरेंट आयंस n plus एंड ऑल ऑफ दैट, ठीक है. एंड व्हाट इज n? n इज नंबर ऑफ इलेक्ट्रॉन्स, इसलिए NFE और MFE. यू आर वंडरिंग m क्यों लिख दिया यहाँ पे? बिकॉज दिस इज द नंबर ऑफ इलेक्ट्रॉन्स. ओके, a few hints from here and there coming there. Delta G minus NFE लिखा था. What was n? N was the number of electrons transferred per mole of this reaction happening. Okay, every chemical reaction में it's electrons that take place. So जाहिर है कि यहाँ पे हम लोग electrons की बात करेंगे. Okay, so how do I get delta G of the whole reaction? कैसे करें? How do we do this? How do we do this? Any inputs? What do we do next? क्या करें? If you remember balancing of equations, reactions, बैलेंसिंग याद है, थोड़ा बहुत बैलेंसिंग याद है, क्या करोगे इन सच अ केस? You multiply this with m, you multiply this with n, and then you will add them together, है ना? Why? Because यार overall reaction में electrons don't make sense. You cannot have excess electrons or deficit of electrons. तो overall reaction में electrons नहीं होते हैं, which is why you do this. So electrons get cancelled out, है ना? What will you get? You'll get Ma gives you MAN plus PM plus MB plus NB. This is what you'll get, and this is your overall reaction, right? That's it. So if I do all of these things, what happens to this? Oh, interesting. What happens to this? So total electrons would be m into n for this reaction. I know मैं कुछ algebra लिख रहा हूं, but take it as 2 or 3. No, क्या फर्क पड़ता है? LCM ले रहे हैं. That's what we are doing. So total reaction would have summation of this. Okay. So delta of the third reaction is going to be m into delta G1 plus m into delta G2. That's it. And E naught finally क्या होगा? Number of electrons in the overall reaction. I've just shown it to you. It's no big deal. Don't get scared by the arithmetic. कुछ नहीं है. When you put numbers, it'll be easy. Put 2 or 3. No, you'll understand what is happening over here. And hence they all get cancelled out. So it looks like, because of this, it looks like you can add. You can add this, which is interesting, right? मैंने बोला अभी कि भाई E naught add नहीं कर सकते हो, and then here and the end I'm saying E cell में add कर सकते हो. The reason why you can add over here, because the same number of electrons are being added on the reduction side and the oxidation side. That's kind of obvious, but a big word of caution over here. You can do this only and only if end में you have no electrons remaining for the reaction that you want to talk about. Okay, this is important. This is important. We'll talk about what I'm saying अगले क्लास में. इसका implication अगले क्लास में देखेंगे. ठीक है. Now, remember we spoke of standard reduction potential, standard oxidation potential. हम लोग एक काम करते हैं. Let us talk only about SRP, and SOP is going to be equal to negative of SRP. This is fine, ना? ये तो this is okay, right? So in terms of reduction potential, we can say that ठीक है, कैथोड पे रिडक्शन हो रहा है तो पॉजिटिव हो जाएगा, एनोड पे ऑक्सीडेशन हो रहा है तो उसको नेगेटिव कर देते हैं. तो ओवरऑल ई सेल इज गोइंग टू बी ई नॉट ऑफ रिडक्शन और ई रिडक्शन, नॉट ई नॉट. ई सेल इज गोइंग टू बी ई रिडक्शन at the cathode minus E reduction at the anode. This is important. This negative sign comes into picture because originally anode पे तो होता है oxidation, but I want to know उसका reduction potential क्या है. Simple, I will use this negative sign, hence there's a negative sign over here. I could also write it like this. I could write as E naught oxidation of anode minus E naught oxidation of cathode. It's the same thing. You see? Any doubts in this part? ये मेरे सर के ऊपर लिखा है. Any doubts here? Anything you don't follow here? Please let me know. This is important. बताइए अगर इसमें कुछ डाउट है तो. काफी जरूरी है. बताइए बताइए बताइए. This good? All right. Yeah? We good? Cool. Let's move on. So, इन दोनों में जो फर्क आ जाता है, that is what you call EMF or cell potential. So here is the quick question. Now everybody wake up. काफी थियरी हो गई लाइफ में ना. अभी अगले 10 मिनट सिर्फ सवाल करते हैं. That's how we roll. Okay. Take these E naught values. What is the standard reduction potential of this equation now? बताइए. मैंने कुछ दिया है E of Fe3 plus to Fe2 plus E naught of Sn2 plus to Sn. इसका क्या होगा बताइए मुझे. What do you think? Answers please in the chat. Since सबको समझ में आ गया तो प्लीज बताइए. Yeah, very doable, right? Not complicated at all. That's how electrochem is actually बहुत straightforward. It may seem like there's a lot to do, but it's really not. Really, not saying this just to give you guys an ego boost or confidence boost. Here all you've got to do is figure out oxidation का और reduction क्या हो रहा है. This is oxidation, this is reduction, and look at the values that are given. You have been given reduction potential values. Okay, and what was E? Overall E क्या था? Let's take reduction कहाँ पे हो रहा है? Fe वाले में. Okay, so take it as it is. Oxidation यहाँ पे हो रहा है, so I have to put the negative of that. So minus 0.14. ठीक है? This becomes 0.91. That's the answer. That's the answer. Yeah, absolutely. Pretty straightforward. All right, let's look at a few properties of electrode potential. It depends on the concentration. We will see how in part 3. It depends on nature of metal. I told you, right? Tendency. वो metal की tendency है. This we'll do in part 2 in detail. Nature of electrolyte. This is interesting. Nature of electrolyte. Yeah, you've got zinc Zn2 plus. That's great. If you put something else, not. And also dependent on pressure, temperature, conditions, especially when you have gases that are being formed or not. That's important. It's an intensive property. It does not depend on how much solution you take. It doesn't depend on thickness of metal and all that. Thoda sa bhi metal ho to it will work. Okay. It does not really depend on this idea as well. Stoichiometric variation of a given cell reaction. Matlab, if I take this or 2 or 10, it doesn't matter. Because actually kya ho raha hai ki in a reaction, you have 10 power 23 electrons or stuff, right? So a lot of particles are happening. Uske bawajood bhi E naught remains the same. So it doesn't matter if I do once or twice or reaction, jo bhi karo, it doesn't matter. These reactions are made for our convenience. Okay. And this is something I already told you, बहुत बार मैं उसको बता चुका हूँ. If you reverse any chemical reaction, उसका sign opposite हो जाता है. ठीक है? Cool. So reduction is the opposite of oxidation, hence sign also बदल जाता है. So here's the question. If you take this sort of a reaction, you've got F2, which is fluorine, which is a gas, accepting 2 electrons, becoming 2F minus, which is an aqueous solution. इसका E naught is given to be 2.8 volts. So what is the E naught for half of this? This is just to check if सब लोग सो रहे हैं या फिर कोई जगा हुआ है. This is not even a question, to be honest. What do you think the answer to this is? It's not going to change, right? It's simply going to be 2.8. कोई फर्क नहीं पड़ने वाला है, right? If I take half करूँ 10 times करूँ, it's not going to matter. Next one. Any redox reaction occurs spontaneously if, and this could have more than one correct answer. Okay, so be careful of this one. Yeah, exactly. A. Any redox reaction would occur spontaneously if, which of these do you think? Spontaneously. अपने आप हो जाएगा. I've told you this from the starting. Yeah. And these are the kind of questions that actually come in your tests. I'm not making this up. Just from this first session, there are possibilities कि ऐसी चीजें test में actually आए. Yeah. D is negative, positive. बिल्कुल सही. Good job. Excellent. Yeah. Excellent. This is spontaneous. And remember, delta G was minus NFE. So, yeah, simple stuff. Next question. Do we have time for this question? Or maybe do we do this next time? I think we have some time. But let's do some other questions. Then we'll come back to this one. We'll come back to this question. Let's do some more questions. When a clean strip of zinc metal is placed in a solution of CuSO4, a spontaneous reaction occurs. Which of the following observations are made? मतलब कि मैंने साफ किया जिंक को and I've put it in copper sulfate. ठीक है? A spontaneous reaction occurs. अब ये लोग बोल रहे हैं कि reaction हो रहा है. There's nothing for you to know. You can just go ahead and figure things out from this setup. They're saying that some reaction happens. ही reaction हो सकता है भाई. क्या होगा? And you've studied this in 8th, 9th, 10th standard as well. Displacement reaction बोलते हैं. हमने 11th के starting में भी ये पढ़ा है. There's a displacement reaction. उसमें क्या क्या होगा? Displacement में क्या होगा कि zinc will dissolve. And ठीक है, zinc dissolve है. फिर क्या रहा है? Copper will get deposited. Is it? Copper, हाँ मतलब डिपॉजिट भी हो सकता है और नीचे जाके गिर भी सकता है. डिपेंड्स नो. थोड़ा सा डिपॉजिट हो जाएगा, अगर और बढ़ रहा है तो नीचे जाके गिर जाएगा. राइट. सो टू मी दिस इज वेरी ऑब्वियस. दिस ऑल्सो सीम्स टू मेक सेंस. मुझे, इफ यू फील दैट इज डिफरेंट, यू लेट मी नो. आई फील बोथ ऑफ दीज मेक सेंस बिकॉज व्हाट इज द रिएक्शन हैपनिंग? दिस इज द ओवरऑल रिएक्शन. ठीक है. द रीजन मैंने SO4 माइनस नहीं लिखा है बिकॉज वो मायने नहीं रखता है. वो पहले भी सोल्यूशन में था, बाद में भी सोल्यूशन में रहेगा. इसको, इस टाइप की चीज को बोलते हैं स्पेक्टेटर आयॉन्स. पहले भी था SO4 माइनस, बाद में भी रहता है, वो पड़ा रहता है आराम से. तो जिंक गिव्स जिंक 2 प्लस, कॉपर गिव्स कॉपर, कॉपर 2 प्लस गिव्स कॉपर. ठीक है. तो कॉपर कहाँ जाएगा? either on plate or नीचे or somewhere over here you get deposited. So because this forward reaction is happening, zinc पतला होता जाएगा. ठीक है. Interesting. Okay. Last wala point is even more interesting. Temperature of the solution decreases as an endothermic reaction. I don't know, to be honest. Is it? Don't know. We'll have to see. What about this one? The solution remains electrically neutral. Yeah, of course. Why would it not? Why would it not remain neutral? Well, if I had some way of moving electrons out, then maybe it may not remain neutral. But यहाँ पे तो जो भी electron बन रहे हैं, this is the overall reaction, right? This is the overall reaction. जो भी electron निकल रहे हैं, the same electrons or similar electrons are being, consumed by copper. So it is neutral. Nothing. It's not like तुम उसको हाथ में पानी में डालो, तुमको शॉक लगेगा. That's not what's happening. शॉक कब लगेगा? अगर इलेक्ट्रॉन हैज अ टेंडेंसी टू फ्लो, तब शॉक लगने के चांसेस है. ठीक है. गैल्वेनिक सेल में पकड़ोगे, छुओगे तो तुमको शॉक लगेगा, क्योंकि देयर इज अ टेंडेंसी ऑफ इलेक्ट्रॉन्स टू फ्लो. बहुत कम शॉट, 1.1 वोल्ट से कुछ नहीं होने वाला है. ठीक है. बट या, these are that are right. Okay, next one. Which of the following is or are correct about galvanic cell? It is also known as voltaic cell. It is an electrolytic cell. A galvanic cell produces electricity as a result of spontaneous reaction, and delta G is less than 0. अगर C सही, C दो बार, if the last option is correct, then C also will be correct. Let me fix this. Hold on. This is slide 9. Excuse me, 93. एक minute. So if option D is correct, then option C should also be correct. Okay, that is for sure. And this is just a definition, man. Voltaic cell बोलते हैं इसको, galvanic को voltaic बोलते हैं. It cannot be electrolytic because अपने आप हो रहा है, spontaneous is not going to be electrolytic. So A, C, and D should be correct over here. I'm not saying this is a JEE advanced question just because I have more than one correct. But hey, now this one, इस वाले में थोड़ा सोचना पड़ेगा. इस वाले में थोड़ा सोचना पड़ेगा. Yes, था बिल्कुल सही. What's up? Consider the cell potentials E Mg2 plus to Mg equal to minus 2.37 volt and Fe3 plus to Fe being minus 0.04 volts. बेस्ट रिड्यूसिंग एजेंट क्या होगा? थोड़ा रेडॉक्स का आइडिया तो यहां लगाना पड़ेगा. हाउ डू यू सॉल्व अ क्वेश्चन लाइक दिस? व्हाट डू यू थिंक? थोड़ा सोचिए. आई विल गिव यू अ मिनट टू थिंक. इफ यू आर नॉट एबल टू फिगर आउट, मैं हूं. आई विल हेल्प यू आउट. थिंक अबाउट दिस वन. दिस इज इंटरेस्टिंग. व्हाट डू यू थिंक? Yeah, I feel this one's fun question. What do you think? I'm trying to adjust the 2 plus to take its rightful place above magnesium. अभी कहीं और बैठा हुआ है बेचारा. All right, I fixed that. This type of question is asked in the mock test. हाँ, mock test में आता है, actual JEE में आता है, NEET में आता है, AIPMT सब जगह आ सकता है. This is an actual question. Okay, अभी तक तो हम लोग थोड़ा बहुत रिवीजन कर रहे थे, चिल कर रहे थे. This is an actual question that could come in the exam. What do you think? शर्मा जी बोल रहे हैं D इसमें. महक is saying A and C in last one. बिल्कुल सही. AC और D भी था महक उसमें. BN शर्मा AC और D था. Yes, D था. इस वाले का क्या होगा? How do you tell, boss? अच्छा सोचो. Reducing agent मतलब it facilitates reduction, so it gets oxidized. मतलब खुद चाहता है कि ऑक्सीडाइज हो जाए. अब ये तो रिडक्शन पोटेंशियल दिए. So let us reverse these reactions. On reversing these reactions, I get Mg giving me Mg2 plus. और इसका स्टैंडर्ड ऑक्सीडेशन पोटेंशियल भाई साहब इज ह्यूज, 2.37 वोल्ट, वेरी बिग. As compared to this, where you have Fe giving Fe3 plus, I know electrons है, मैं नहीं लिख रहा हूँ, let's just write like this, keep things simple. This is just 0.04 volts. You know, right? If I reverse the reaction, I have to change the sign. So look at that. This has the biggest sign. मतलब कौन सा हुआ reducing agent? Mg2+ या Mg? I've done half the job for you. Okay, clearly this 2.37 number is big. That should be the answer. Now what is a reducing agent? Reducing agent मतलब it wants to get oxidized. What wants to get oxidized? Magnesium ही तो oxidize होगा. Mg2+ कहाँ oxidize होगा? वो तो already हो चुका है. तो answer would be magnesium. And this is an extension of the redox में जो आपने ideas जो पढ़े थे. Nothing new. Okay? Any doubts here? Are you good? Are you able to follow how I got to C? Good attempt, Tirthraj, but it won't be A, it will be C, because reducing agent वो होगा जो खुद oxidize हो चुके. Oxidize Mg हो सकता है, Mg2+ oxidize नहीं हो सकता है. Here I am, आप बोल रहे थे B, but it will not be B. If you say it is B, वो तो non-spontaneous reaction है ना. Fe3+ to Fe is non-spontaneous. पहली बात तो ये हो गई. दूसरी बात, it is not reducing agent, it will be oxidizing agent because ये खुद reduce हो रहा है. It doesn't make sense. थोड़ा सोच लीजिए. Here I am. नहीं, here I am. वो सब मत करिए. Don't mug that. See, that is exactly what I was trying to build a base. So you don't mug that. ये concept ना, reducing agent as you go down the electrochemical series ये होता है. As you go up the electrochemical series ये होता है. Please don't do this. First principle से करो. कुछ mug करने की जरूरत नहीं है. What is the first principle? I've told you. आराम से we are figuring it out together. Okay? Did you figure it out now? अभी समझ में आया? मैंने लिखा ना. I know you are in a hurry writing something down, but just look at this. यहाँ पे जो लिखा हुआ है, and this is quite direct. Magnesium should be the reducing agent. It's okay, Tirthraj. I hope you've understood now. Last question अभी के लिए, बाकी you can do as a homework. ठीक है? Which of the following is or are incorrect? Greater the reduction potential, greater will be tendency to get oxidized. Incorrect. Electrode potential depends on nature of metal. ये तो सही है. Hence not the answer. Electrode potential cell potential are extensive properties. Galvanic electrocell cells are reverse. ये भी सही है. तो इन दोनों में से देखना है कि कौन सा गलत है. कोई गलत है, दोनों गलत है, एक गलत है. ये वाला देखते हैं. This seems like it's easy one out. Electrode potential, cell potential are extensive properties. No, they are not. They are intensive. Since ये intensive है, तो this is my answer. Okay. Incorrect पूछना था. Greater the reduction potential, greater will be the tendency to get oxidized. अगर reduction potential ज्यादा है किसी चीज का, मतलब से x2+ giving me x, it has a value of say 3 volt. That means greater the tendency to get oxidized. No, it will be greater the tendency to get reduced. What is reduction potential? Reduction potential is xm plus giving you x plus m electrons. This is reduction potential. ठीक है? E0 वैल्यू इसकी अगर पॉजिटिव हुई, बड़ी हुई, मतलब the forward reaction is spontaneous. Forward reaction क्या है? Forward reaction is reduction. Okay, it is ulta this way. It's reduction. Forward reaction is reduction. ठीक है? So greater the reduction potential, greater the tendency to get reduced. ठीक है? We good? है ना? उसमें था ना. Here I am. आप जो बोल रहे थे. F2, it accepts electrons and becomes F minus. इसकी वैल्यू है 2.37 और 2 point something 78 जो भी कुछ some value. What does this mean? It really likes doing that. So it likes being reduced, not being oxidized. That's it. So A and C should be the answer to this. Take this as the homework question. Okay, take some time and do this. And let me know in the comments what's the answer to this. This is the homework question. Suman ji, क्या बात नहीं समझे? Which part did you not understand? What is reduction potential? Tendency to get reduced. अगर वो reduce होना चाहता है तो वो oxidize क्यों होगा? Reduction potential का यही मतलब है ना कि कोई पॉजिटिव आयन बन रहा है अनचार्ज और an uncharged species is becoming negatively charged. That is reduction. है ना? Reduction क्या होता है? Acceptance of electrons. तो अगर reduction potential ज्यादा है तो उसकी tendency to get reduced, not oxidized obviously. ठीक है? Cool. That's the homework question. Please let me know in the comments what the answer is. That is the last idea for today is कि हम लोग जो है ना ये डिफरेंस कैसे पता कर रहे हैं? How are we getting this delta E values? हाउ? वी हैव टू कंपेयर इट टू समथिंग. मैंने बताया था ना कि भी पॉजिटिव, नेगेटिव और जीरो. व्हाट इज दिस जीरो? दिस जीरो मस्ट बी द रेफरेंस. नो, रेफरेंस हो गया तो उसके अगेंस्ट करेंगे. दैट इज द स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड. ओके, स्टैंडर्ड रेफरेंस इलेक्ट्रोड इसको बोलते हैं. क्यों? जबरदस्ती. ऑनेस्टली दिस इज जस्ट रैंडम. आई एम नॉट मेसिंग विथ यू. दिस इज रैंडम. हाइड्रोजन इज अ रिड्यूसिंग एजेंट. मेटलर्जी में आप पढ़ते हैं, नो मेटलर्जी नॉट योर सिलेबस, बट हाइड्रोजन इज रिड्यूसिंग एजेंट. बट वी से दैट arbitrarily we say electrode potential इसका जीरो है, just so that इसका कुछ रेफरेंस ले ले. So we measure everything with respect to SHE. ठीक है, स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड. अगर हम लोग इसको एनोड पे रख लें, मतलब कि जो दूसरी स्पीशीज है वो रिड्यूस हो रही है. दूसरी स्पीशीज कौन सी हुई? एनीथिंग, इट कुड बी एनीथिंग. ओके, सो ऑक्सीडेशन पोटेंशियल इसका हो जाएगा व्हाटएवर, दिस इज गोइंग टू बी जीरो. एंड रिडक्शन पोटेंशियल हो जाएगा इसका, दैट इज आल्सो जीरो. Either way it does not matter. ठीक है, this is the reduction, this is oxidation. Either way, negative of zero is still zero. So this is just a way of showing you कि आप reaction कैसे लिखोगे. इसके बाद क्या करना है? Yeah, you basically measure the potential and it gives you the value of this E naught जो हम लोग अभी तक पढ़ रहे थे. वो कहाँ से आता है? This is how you do it. So if I take say anode पे zinc and cathode पे SHE, SHE मतलब standard hydrogen electrode. Then I get E naught की value to be 0.76. कैसे? देखो कैसे मिलेगा. What is E naught cell? This is cathode minus anode. Correct? ये जीरो है. This is minus of some number. And you get negative 0.76. खत्म. Okay? Cool? Alright, you're most welcome, Sumant. So, sorry, lost my train of thought because of the comment. So, I measure this. And if I get this idea here, then from that I get, oh, look at this. E naught of Zn to Zn2 plus is negative 0.76. तभी तो ये positive value हुई. Whatever I'm measuring against hydrogen, I want the overall cell to be spontaneous. And accordingly, I put it at the anode or the cathode. It doesn't matter. So, इसका ये मतलब हुआ कि zinc likes being oxidized, but मैं जबरदस्ती उसको reduce कर रहा था, तो इसलिए negative value आ रही है. If I try and reduce it, it has a negative value. That's what I'm saying. Negative 0.76 with respect to hydrogen. Okay. Okay. Similarly, ये हम लोग रिडक्शन पोटेंशियल भी कर सकते हैं. एंड वी अरेंज देम इन अ सीरीज, इलेक्ट्रोकेमिकल सीरीज को बोलते हैं, जिसके बारे में हियर आई एम बात कर रहे थे. दैट वील टॉक अबाउट इन द नेक्स्ट सेशन. ठीक है, ऑलराइट, दैट वाज ऑल दैट आई हैड प्लान्ड फॉर यू टुडे. एंड अगेन, होमवर्क क्वेश्चन क्या था? ये वाला था. इट विल टेक अ लिटिल बिट ऑफ एफर्ट. We'll solve it if you guys want to the next class. But it'd be nice if you guys go ahead and let me know and I don't have to solve it, because you making the effort is what matters to me the most. Okay, I can still solve it for you if you want, but you should understand what's going on. So आज हमने क्या किया? We figured this out. ये जो scary सा अजीब चीज थी, we figured it out now. ठीक है? We have done this. We have done galvanic cells. We have done all of these things. We have done this as well. Measurement of electrode potential हमने कर दिया. ठीक है? ये सब किया है. ये सब किया है. ये सब किया है. It seems like we've done quite a bit, huh? We've done this, and this is what we're going to do in the next thing. But before we do this, हम लोग Nernst equation से पहले इस चीज की बात डिटेल में करेंगे. So part 2 actually is this table. जो electrochemical series आपको दिख रही है NCERT, will talk about this. Nernst equation we'll do later. It's okay. It's important and all that, but most likely we'll do that in the third session. We're going to focus on electrochemical series in the next session. Reduction and oxidation, all that. ठीक है, NCERT पढ़ के आना, सवाल सॉल्व करते रहना. I'll see you around. Thank you so much for joining in. And if you want to check out my other content, you know where to find it, right? Go to the pinned comment right over here. If you want to join Discord for discussions, besides this, padhai ke bare mein, anything, Telegram, Discord, and you want to check out my other sessions generally on the JEE channels, all YouTube links are on this bento thing right here. You want to download the app, which has awesome animations and everything else that's brilliant? Second link on the pinned comment. All right. I'll see you around. अगर if you feel like शाम को 8:30 बजे I'm going to do atomic structure by the way on the JEE channel. Come check that out. We're going to talk about quantum numbers. A lot of fun questions. ठीक है? मिलेंगे. Bye. Good night. See you around. Tata. We'll continue this. करते रहेंगे. Oh, by the way, next का 2022 का पेपर I'm going to do on Monday. ठीक है? चलो. Bye. See you. मैं, if there's anything that you didn't follow, you can ping me on Discord or on Telegram and I'll give you more resources. We'll chat and we'll figure it out. There are a lot of awesome students who can help you as well. You know these links. You can join in and we can chat about them. Okay? एंड इफ देयर समथिंग यू डोंट अंडरस्टैंड ना, चैट में उसी समय क्लियर कर लो, बिकॉज यू आर मेकिंग द एफर्ट टू अटेंड दी सेशन लाइव. आई वांट यू टू टेक समथिंग पॉजिटिव आउट ऑफ इट. जो नहीं समझ में आ रहा है ना, पूछ लो. आई एम हियर टू हेल्प यू. डोंट वरी अबाउट टाइम एंड ऑल दैट. नन ऑफ इट मैटर्स. माय मोस्ट इंपॉर्टेंट थिंग इज दैट यू शुड अंडरस्टैंड. ठीक है, चलो बाय, टाटा.